Hi. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Let's wait a couple of minutes for a few more people to join in, and then we can get started.
Hello, everyone.
Okay, I think we have the critical mass. Again, I welcome you all to this webinar on Windows Server Monitoring. Uh, we are extremely excited to have this session with you. It's a long awaited feature. And Netdata 2.0 for us was a big landmark release. One of the things, of course, which we released and introduced to the world is the native Netdata agent for Windows servers. And today I have with me, I'm Satya from the product team. I have Sham, who's also from the product team, who will be taking you through the Windows Server monitoring. So without any further ado, the ball is on your court. Sham, go ahead.
Thank you, Satya. Yeah, so like Satya mentioned, the Windows native agent for Netdata has been something that users have been asking for a really long time. So it's been a long time coming, but we finally got around to doing it and dealing with all the intricacies of Windows. But it's been an interesting journey so far, and we hope that a lot of users will be able to get a lot of value out of this native agent. So let's jump right into the webinar now. So I want to start by setting the stage a little bit about why real-time monitoring matters. And of course, it sounds like a very obvious statement that, real-time monitoring should matter. Everybody wants real-time and everybody wants to monitor their servers. But the key here is in the term real-time and what is the definition of real-time. Because there's a lot of different definitions out there for that term. But at Netdata, when we think about real time, the only thing that we think about is per second granularity, which means that you have to be able to see every single metric, every single log, every single second as it happens. And that real time aspect kind of translates to everything else as well. So it translates to alerts, anomaly detection, anything that you do in terms of monitoring and observability. If you do not have that real time view, then you lack fidelity into your data and you're missing out on things. So, as all of you know, IT infrastructure keeps on growing more and more complex. Uh, 87% of enterprises today have a hybrid cloud strategy, um, either fully implemented, partially implemented, or in planning stage. And it usually involves a mix of on-prem servers and cloud-based servers. The other thing that sometimes people from a more Linuxy background underestimate is how prevalent Windows still is. So almost three quarters of enterprise environments still include Windows servers in some form or fashion. And there are a lot of enterprises out there where, Windows is the majority of their workloads still. So sometimes we underestimate this a little bit, but we've been finding this out more and more as we talk to more customers, especially large enterprises where there's usually some Windows servers as part of the mix as well. And ideally for the admin team, for the SRE team and the DevOps guys, you would prefer if you can monitor all of your infrastructure with one tool, a single pane of glass. You don't want to have to use a dozen different tools. And the thing with complexity is that it increases risk. So if you can't fix what you can't see. So if you're not getting the right metrics, if you're not getting it at the right granularity, that means that there's problems and underlying issues there that could lead to outages. You're just not seeing them yet. And that brings us to the second point of downtime, performance issues, and outages, and the real cost behind this. So this number there is from a study that was conducted by Gartner a few years ago, that the average cost of downtime, and this is average across all kinds of companies, the small ones, medium ones, and the big ones, is $5,600 a minute. For the bigger companies, the cost of downtime is much higher. This is just the average. But you can see how even just a few minutes every month, or even few minutes a year, is a huge cost, which means that anything and everything that you can do to prevent downtime and to catch these performance issues earlier, is worth its weight in gold. The other key point there is that nearly half of performance issues across all kinds of enterprises are being identified after end users complain. Right? And this isn't something which should come as a surprise to any of us. We've all used services and products and tools where we found issues, we've complained about it, and sometimes even after complaining about it, it takes a long time for things to get fixed, if they do get fixed. But this is again a problem. This means that the development teams, the people who administer these products and software, they're not able to identify these things in time. So they don't have the right visibility into their own tool set. And then finally, there we talk about MTTR, which is the mean time to recovery. So assume worst case, something goes wrong. How soon can you actually get to the root cause and get things back up and running? So this is what at Netdata we call this, the 3 a.m. troubleshooting time, because things usually go wrong at exactly the wrong time, not at the right time. So in the middle of the night, you get alert notifications, you need to log in, and you need to figure out what's going on. So the numbers that we're talking about here, and we'll talk about a few more in the coming slides, these are not numbers that, they're not magic numbers. They're what our customers have shared in our public case studies, that our troubleshooting tools that come as part of Netdata really help them reduce their mean time to recovery, because they can get to the root cause faster. So now, we talk a little bit about why traditional monitoring tools, especially in Windows environments, have been falling short. And the primary reason for this has been the lack of data granularity and the low data fidelity. On Windows, it's still prevalent that legacy observability solutions and monitoring solutions are being used. So these are solutions that were designed, in the early 2000s, which means that, of course, they look old in terms of their look and feel, but they're also dealing with timelines that are not suitable for today's world. So we're talking about collecting metrics every 5 minutes, every 15 minutes. You're getting the data, but you're not getting enough of it to actually tell what's going on. So if you're managing critical systems, the data collection is just too slow for it to actually help you. So this is actually a very dangerous situation to be in, because when you look at it at a surface level, you have the data, right? So you're monitoring the CPU, you're monitoring the disk and the memory, you have all these metrics, and the metrics are telling you the wrong story because the granularity is really poor. So if you have a 5-minute interval, that means that every hour you're getting just a few data points, which means that any fluctuations, any spikes, any minor disruptions, all of that is just getting smoothed out in this 5-minute interval, and you're getting one number at the end of it, which may or may not tell the right story. So the lack of granularity means that you're missing micro outages and these transient issues, which eventually will lead to the actual outage or the actual performance issue that you're trying to prevent. So real-time monitoring is actually a mix of being able to get highly granular data for faster insights. This will enable you to do faster decisions, especially when you're troubleshooting. And in effect, it'll lead to minimal disruptions. It'll help you to bring that downtime number down. So what makes Netdata different, right? So we talked about some of those legacy tools there. Now let's just focus on some of the key things that Netdata does differently. And you can see Netdata's dashboard in the middle of the screen. For those who haven't seen this before, this is a preview of how it looks. Um, the key difference between Netdata and almost every other tool in the market when it comes to observability is that Netdata collects metrics at a 1 second granularity without fail. So every single metric that Netdata collects by default is at a 1 second granularity. 1 second is our default. Of course, you can change it if you want to, but by default, Netdata is collecting everything at 1 second. The second thing, which kind of goes hand in hand with the first point, is that we collect an unlimited number of metrics. So this is where we talk about the concept of high fidelity. Fidelity is actually a mix of how frequently you can get the data and how much data you can get. So when you put those two things together, the fact that you're getting data every single second, and also that you're collecting thousands and thousands of metrics. So even on an empty VM, you're getting upwards of 2,000 metrics with Netdata. Now you might question whether do I really need all these metrics? What am I going to do with 2,000 metrics? Well, our philosophy is that you never know when you will need them. You might need them at the middle of the night while you're troubleshooting an issue, and you don't want to then decide retroactively that, oh, maybe I should have had that. Now let me go and add that metric. So we're going to have all those metrics there. We're going to do our best to organize them so that you're not overwhelmed with all the data, but all of it's going to be there, and all of it's going to be real time. And also, since you have a lot of metrics and you're getting them every second, how are all these metrics stored? So how does this make sense? So we also talk about unlimited retention. So what does this even mean? So maybe in one of the upcoming slides, I'll talk a little bit about Netdata's architecture, which is again quite different from how you would normally see in one of these monitoring solutions, because Netdata's architecture is distributed or decentralized, which means that each agent stores its own data. This allows us to do data retention, which is completely up to the user, up to the customer. So depending on how much storage you have available, and you don't need to have it available in a single server, but distributed across your infrastructure, you can choose how long you want to retain data for. And Netdata has different tiers of storage. So if you say that you want your 1 second data for 2 weeks or 3 weeks, but then after that you want to digest it and keep 1 minute data, and after maybe 6 months you want to digest even further and keep 1 hour data, you can do that for even up to years, because the storage is really optimized. And this leads to the next point, because the data storage happens locally in the user's own infrastructure. So the data always stays on-prem. It's always stored on-prem. And when you're using Netdata Cloud, what happens is this distributed query that pulls in data from across all of these agents, across all of your infrastructure, and displays that data in the dashboard. But it's not stored on Netdata Cloud anywhere. It's just pulled directly from your on-prem infrastructure, and it flows through Netdata Cloud into your browser where you see it. When you turn off the browser, it goes away. The other cool thing about Netdata is that we do anomaly detection, and again, we do it a bit different, in a bit of a different way. So anomaly detection happens at the edge. So again, it happens on the device. And this is, again, really important for accuracy as well, because you could have the exact same metric on 2 different servers, and what is normal on one server might not be normal on the other server. So the metric could have exactly the same value, but depending on the workloads that are running on that server, that same value could be anomalous on one system and normal on the other system. So this is part of the reason why we do it at the edge. The other reason is that we want to do this as close to the place where the data is being generated, ingested, and stored. And Netdata Cloud allows you to kind of, again, distributed query all of this information and overlay it on top of the charts. So anomaly detection is not a feature that you have to go and enable. It's enabled by default, and it's available on every single chart that Netdata has. And it's built based on unsupervised machine learning models that are really lightweight, which enables it to run on any kind of infrastructure that you have. And finally, it's our philosophy of zero configuration. So everything that we do, we try to do it in a way that the configuration burden is as low as possible, which means that we want you to get value out of Netdata as soon as you install it. So it shouldn't be that you install it and then spend days and weeks building dashboards, uh, learning a query language, figuring out how to populate your charts. All of that should just happen out of the box. Even the alerts should be available out of the box. This is the Netdata philosophy. Okay, so let's jump into a demo now, and I can talk about how you can install the Netdata agent on a Windows server, and how you would actually visualize the dashboards and look at some of the metrics and the logs and so on. So maybe I can take over the screen sharing. Satya.
Yeah.
Okay, so what you're seeing on my screen right now is the Netdata UI. This is one of our demo spaces. And you can see there's a lot of different rooms into which we have organized different nodes. We have a Windows specific one here. So in this case, it already has Windows agents installed, and this is what you're seeing. But I'd like to show you how this would look in a new if you're installing a new Windows agent. So you have this Connect Nodes button here that you can click, and it opens up this tab here, which by default, it's going to show you how to add a node for Linux. But then if you click on Windows, you get this information here. So there's two ways you can do this. Since it's Windows, we offer a GUI-based MSI installer. So all you would need to do is just click either on the stable version or the nightly version, and it would download the file. So let's just try that out. So I'm downloading the MSI installer now, and I can just double click and install it. Or I can just copy this command. So this is what we call a kickstart command on Netdata. You can just copy it by clicking on this, and then just open Windows PowerShell with admin privileges and just paste this. That's it. So it's one single command. And what this command is actually doing is it's going to download Netdata's latest image, the MSI, the same thing that you would have done manually here. And it would install it in silent mode, and then it would connect it to this cloud space that we're on by providing the right token, the room ID, and so on. Of course, you can do some of that manually if you'd like to. After downloading the installer, you can use the terminal and install it. But this is the preferred option because you can do it silently across multiple systems if you wish to, and it just takes a minute or two. So within a couple of minutes, you would immediately see the screen that I'm showing you right now. All of the charts that you see here are out of the box. We've not done any custom work here. All the metrics that you are going to see are all automatically discovered, and you can try this out for yourself. Once you install it, within a minute or two, you get the real-time dashboard. So for those who are new to Netdata, I can quickly give an overview of how things are organized here. So we have different tabs on the top here. The first tab is called the Home tab. It's excuse me. It's a sort of a summary view of how many nodes you have in this room. In this case, we have 2 Windows nodes here. The nodes lists each node with a kind of a quick summary of the metrics that you want to see about it. In this case, I'm showing CPU, memory, disk, read, disk write. You can customize this if you wish to. And then the Metrics Explorer tab. So this is where you would spend most of your time if you're actually doing any monitoring, troubleshooting activities. And you can see that Netdata automatically organizes the data into different sections. So under the system metrics, you have things like compute, memory, and memory itself is organized into RAM and swap and pool and so on, storage and so on. And the way that the charts are structured is we have different kinds of charts. So for example, I'm in the storage section right now, and you can see that we have summary charts here for disks, which is showing a real-time view of each of these things. So total read IO, total write IO. We have a tabular view of the different disks that are part of this setup. And then for each metric, you have these real-time charts, right? So these are time series charts. And you can think of each chart almost like a dashboard of its own, because there's a lot you can do to it. There's a lot of customization that you can build around this. So for example, I was on a call with a customer today, and they were asking if Netdata offers a query language or something which they can use to build their own chart, decide how things should be aggregated, how they should be grouped and visualized. And the neat answer to that question is that there is no query language. You can do everything directly from the UI. So in this chart, for example, it's grouped by dimension, but I can choose to group this by disk, by percentage of disk, by all of these different things. If you have a custom label, you can group it by that. You can choose how the aggregation is done, whether it's average, sum, min, max, how many nodes and which nodes the data is coming from, which disks the data is coming from, since this is a disk-related chart, which dimensions you want to visualize, which labels. Again, you have device ID here, for example. You have the model of the device, but you could have any number of custom labels. You can create your own. And also the time aggregation. So instead of average across time, if you want to use percentile, or there's a lot of different statistical methods here that you could go into as well. All of those options are available to you. You can also choose how you want to visualize the data. So if you don't want to use the standard thing that Netdata is offering, you can, of course, choose your own chart type. And when you've made all these changes, you can save your setting in user settings. You can either save it for yourself as a user or for all the users if you're an admin. And if you want to create a custom dashboard, it's just as simple as just dragging this chart and dropping it here, and that's it. You've just now created a custom dashboard. So it's really fast, and it's really easy to do almost any level of customization that you want to do. So this is Netdata charts in a nutshell. And let's
maybe
say
just
that
maybe just
yeah,
one
go
thing
ahead,
that I
sir.
want to call out is, although you can do all of this, Netdata does this for you. So each chart is basically built with experts that we discuss with, how each chart is grouped, how it's aggregated, all of this, and how the chart shows is all opinionated. So in an ideal world, you would never have to play with all of these. But of course, to slice and dice and during your troubleshooting journey, you can do what you please, and to get the right results, which is
Yeah.
to troubleshoot the issue. Right.
Yeah, I think
Go ahead.
that's a really good point. We always like to say that, of course, you can create custom dashboards, but we believe that you shouldn't need to, or you shouldn't have to, right? Because every single metric is available in a chart. We've done the work to ensure that the charts are being visualized in an appropriate manner. We're talking to the subject matter experts. We're discussing in the community to understand what's the right chart type, what's the right aggregation model, which means that we're trying to save you time and resources and effort in your monitoring journey. So assuming that you want to figure out what processes are running, you can go to the processes section, and it's going to show you how many processes you have running here. If you go to the app section, it'll talk about what these processes are. For example, maybe I can quickly jump to another space where I have a couple of nodes running. So this is a laptop and a PC, both running the Netdata agent. They're running slightly different versions of the agent. And let me go to metrics. And if I go to apps, you can see that we have the CPU, the memory, the swap related stuff. So now it's showing real-time data. It was paused when I went here in the past. And every single processor application that's running on this Windows machine will be listed here. So you can see, as expected, you have the usual suspects who are using up the memory here. Google Chrome is using up 12 gigs. I have Hyper-V running, so it's eating up quite some memory space as well. But then you have things like Splunk that I'm running here, for example, which is eating up 2.5 gigs of data. Visual Studio Code, Discord, and so on. So this is a really nice way to actually understand what's going on in your system, even if you're not administering hundreds of servers. If you just want to know what's happening on your own system and you're using Windows, this is a really in-depth view into everything that's going on. You get way more juice out of it than you would get out of running Task Manager on Windows, for example. Because you're not just getting a real-time snapshot, you're getting this time series view. So you get to see what happened over time. You get to compare between different devices if you want to. And in case you want to know if there were any anomalies, in this case, every single chart has this anomaly ribbon on top. There's nothing that you see here right now because this is normal behavior. There are no anomalies in these two charts that you're seeing right now, but I can click on this anomaly percentage button here, and it's going to assign an anomaly percentage for each chart here, so that I know that, okay, maybe I should be looking at the memory chart here. There's only tiny levels of anomaly, but you can see that showing up here. And if I mouse over, you can see that there's some purple color here on the anomaly ribbon, and it's telling me that the sync host process was behaving anomalously in terms of memory usage. So even though you have, in this case, you can see there's 200 plus processes and applications running on this couple of servers, you're able to immediately understand which process or which application is behaving anomalously at this point in time. And that changes over time. You can see here it's Quality Windows Audio Video Experience, which is the application. It's some sort of Windows utility, and it's behaving 50% anomalously. So this is a really fast way to do this. And I'm assuming this is because I'm monitoring the exact same machine that I'm using to do this demo. And I'm connected to the live stream. So Windows is doing some audio video experience thing. And it is anomalous because this is not something I normally do on the system. So that's to do with any application or process that you have running on your system. You also have the containers and VMs section here. Because I have Hyper-V running, I have some containers running here. And these are automatically discovered. So if you didn't have any, you wouldn't see this section on the screen. I've not done any special setup to make these charts show up here. I just happen to have Hyper-V installed and some virtual machines running. And you can see that those instances are automatically showing up here. And you have synthetic metrics, in this case, CPU idle jitter, but you can add your own synthetic checks like ping tests or DNS response time checks. And then if you have any Windows level applications, they get automatically discovered as well. So you see here that I have .NET Framework that's running and IIS that's running here as well. So all of this is automatically discovered. I've not done any pre-configuration here at all. And you can see that, for which instance IIS is running, what's being received, sent, requests. And again, everything is being automatically organized into different sections and subsections. The charts are being visualized accordingly. And if there were any anomalies, you would know about it. So all of this is just what Netdata is doing out of the box. And I think in the other server, we also had MS SQL running. So you can see that this is MS SQL is running here. We're able to see how many instances there are, how many users are connected right now, what's the cache hit ratio as a snapshot in the summary dashboard. And then as you scroll down, you can see that we've organized the metrics into SQL level metrics, requests, errors, and then database level metrics. And you can see all of the different databases that are part of this. But then also things like buffer manager, memory, blocks. There's like tons of data. And the idea is that if you have specific services which need custom level of monitoring, application monitoring, we are going to have these sections associated with that. So it will also be there for things like Microsoft Exchange, and Active Directory and things like that. Jumping back to my space here. So we talked about metrics, but Netdata is not just about metrics. We also have uh, real-time information that we can query directly from your system. We put this in this tab called top. It's called top because top is a command that's used a lot on Linux systems. If you just want to know, a tabular view of all the processes that are running and how much resources that they're consuming. But it's not just about top. There's other things that we collect as well related to Netdata's API calls, streaming, and so on. But here you can see this is showing you, a similar view to what you would see in Task Manager. You're seeing a list of all the processes. What is its name? Who is the user it's associated to? How much CPU, memory, uh, and there are these different metrics that you see here. You can customize those metrics if you want to. So it's always showing you a real-time view. So instead of having to, if you're an admin, instead of having to log on to different systems via remote desktop or something to see what's going on, you can just do that from Netdata. And if you want to do it for a different system, you just click on this button, and now I'm going to be querying it live from a different system. So it was just a second or two, and I'm immediately seeing the data. So that's top. And then we have logs. So the logs tab is actually, or what we call the logs explorer. In the case of Windows systems, it's pulling in data from your Windows event logs. So you can see that there's a bunch of event channels here. You can filter by this, of course. So if you want to see data specifically from, overwrite mode, you filter on that. It's going to filter the data by that. If you want to search inside the logs for something, for example, let me try searching for error here, see what happens. You can see that it just took a second, basically. It's already filtered. So it's really, optimized to run as quickly as it can. Even though Windows Event Logs is not known for being highly performant, we've tried to make it as fast as possible for you to explore your logs. And the logs chart here on the top gives you a quick view of what's happening with the errors, the information, the different labels associated to each log. So that's logs. I think we already touched upon custom dashboards. The other section is alerts, right? So here you can see that there is one alert that's being triggered. So on the C drive, I'm exceeding the warning threshold for disk space utilization because I'm using 94% of the disk right now. And in this case, the alert is kind of obvious about what it does, but there are lots of alerts where it might not be obvious to you as a user or as an admin on what are you supposed to do with it. And in cases like that, we've created a Netdata assistant that will help. So if you just click on this button, it'll tell you, what this alert is, how do you troubleshoot this alert, and so on. In this case, it's obvious, so I'm not going to spend time on that. The other
Shyam,
things
I just took the opportunity to put a question that came in from one of our
Sure.
users. It was related to alerts, and it was exactly related to the disk space that you were showing here. Maybe do you want to talk about this, or
Yeah, or
should we?
if you want to take it, you're the alerts guy, so you feel free.
Okay, so Netdata is shipped with out of the box alerts for various system components as well as application components, and disk space is one of those. So Luke, you wouldn't need to create or configure your own alert for anything to do with disk space. And Netdata will automatically trigger alerts when it identifies that the disk space is low. Of course, you can customize the thresholds. So as Shyam is showing, you can go to the alert definition and you can define. So in this case, the alert is triggered at 90% for a warning, and at 98% for a critical. And the clear threshold, so for it to go back from warning to a clear condition, is 80%, and from critical to warning is 90%. You can change and tweak any of these, but also you can create an altogether new alert to meet your requirements, and you should be able to achieve any kind of alerting on system components or application components. I hope this covers your question, but we can also take this later on if you have any more questions. Um, and yeah, I hope we've answered that. Thanks, Sham. I just thought this is the right opportunity for us to
Yeah,
cover this
that
question.
was the right time for that question. Thanks for asking that question.
Yeah, thanks, Luke.
And like we just showed here, you can edit the alert, you can create a new alert, and then you can just directly submit this either to a single node, or you can click on multi-node submit and submit it to all the nodes. So it should just take a few seconds for you to do kind of apply a change to an alert across your infrastructure. Okay, let me come back here. You can see that the alert has now gone away because I changed the threshold from 90% to 95%. So no more active alerts. But let's say that you see an alert, you don't necessarily want to change the configuration, but it's an alert for something that you don't really care about. You think it's fine that this condition is being hit. You can also silence that alert. So you can silence it for a fixed duration of time, or just silence it. That you don't want to be notified about this. It's still going to be shown in the list of alerts, but you won't be notified about it at all. And that brings us to notifications as well. So by default, Netdata is going to send you an email notification when your alert is triggered. But there are a lot of different notification integrations. We have our own mobile app for notifications, but you can use Amazon SNS, Discord, OpsGenie, Microsoft Teams, Slack, PagerDuty. And we have a webhook, so you can basically use anything that you can think of and receive your Netdata alerts that way. So going back to metrics, I think we covered how to install an agent, how the dashboards look, and where you can see the different data points. Maybe Satya, can you share the next slide again? Let's just go over it, and maybe we can jump back into the demo if you need to.
Okay.
Yeah, so I think we covered some of this during the demo. So we showed how to configure an alarm, and if you want to reduce false positives, you can always configure or fine tune the thresholds. So if you see that a particular alert is being triggered very often, but it's not a critical situation for you, you can either silence it, or you can configure the threshold to be at what you would consider a critical value. And you can even link alerts to the anomaly rate, which is triggered from anomaly detection. So you can say that I'm not associating a single hard-coded value for when this alert should be triggered, but let me know, notify me when this metric is behaving anomalously. So anomalously might mean very high or very low. It's just abnormal, right? So the other thing I can quickly show, let me take back the sharing, just to show a little bit of the troubleshooting features that Netdata comes with. Can you go back to my screen share, Satya? Okay, so jumping back here. So the other things that you can do with Netdata in terms of troubleshooting are that, let's say that you see something odd going on for a particular time frame. It might be related to an alert, or it might be something that you just see something odd in a chart and you want to dig in deeper. You can actually select the highlighter tool and then highlight that particular part of the chart, and then you can run metrics correlation on that area. So what metrics correlation does is it basically looks through all of the data that Netdata has for that time interval that you just highlighted. And then, I think this is too big a time window. Let me just look at something smaller for it to be more meaningful. So I'm looking at the last 15 minutes now. And let me go to application CPU. Okay, so I'm going to choose the highlighter, and I'm going to highlight this small spike here. It might be nothing, but so I've highlighted 16 seconds of data, and then I'm clicking find correlations. So what's happened is that even though there were hundreds, maybe thousands of metrics, Netdata has looked through all of them. Yeah, in this case, it's analyzed 878 metrics, and it's found 4 correlated metrics to that time window. So you can see what's happening here, right? So there's TCP-related metrics have been identified for that specific time window. Since I just chose something random, it's not necessarily meaningful in this example. It might be, but if you were actually trying to debug or troubleshoot a specific issue in your infrastructure, this is really useful, because you might think that across my infrastructure, I have thousands, sometimes millions of metrics across hundreds of devices or thousands of devices. How do I figure out what's related, right? Because sometimes in a large infrastructure, the root cause of the problem could have started on one particular instance, and then it sort of cannonballs across different nodes, different applications. But the metrics correlations feature allows you to kind of narrow it down to only the metrics and only the charts which are behaving in similar fashion, statistically speaking, and then you can actually do this in a much more faster, in a much more meaningful fashion. So this is how metrics correlation works. There are some customization options to it as well. Once you get the hang of it, you can try playing around with it, and you can find out what works best for your kind of data, for your workload. And then we talked about anomalies in each chart, but in case you want to explore anomalies across your infrastructure, we also have an anomaly advisor tab. And here you would see the percentage of anomalous dimensions across your infrastructure. In this case, it's across this laptop and this PC. But again, you can use the highlighter tool. You might have noticed there's a small spike here, and you want to know what happened during that time. All you need to do is just highlight. And again, it filters on the specific metrics that were anomalous during that time. So here you can see there's just 5 charts that show up. So this is the logical disk I/O, and you can see that it's the writes dimension on logical disk I/O was anomalous during that specific interval that I highlighted. And there were also page faults. So these things are probably related. And this was an anomalous event. This is not something that keeps happening on this system. So again, the idea with this is that how can you get to the important pieces of knowledge that Netdata is collecting from your system as fast as you can. This is what helps reduce the MTTR, reduce the downtime eventually. And then finally, we have the events tab as well, which is, you can think of this as an audit log. It contains all of the events that Netdata recognizes. It might be administrative events, it might be alerts related events. So in this case, you can see that the disk space usage alert was cleared with 94.1% because I changed the threshold value. So I think that covers it for the demo. And of course, if there are questions later on, we can jump back in at any time. But let's head back to the slides now. If you can go to the next one, Satya. So we talked about the features that make Netdata different. Now we're covering the difference that Netdata can actually make for you once you start using it. And all of the numbers that you see here or most of the numbers that you see here are coming from our users and our customers. So I've put the source link on the bottom there so that you can see it for yourself. These are our public references to case studies. So if you go to netdata.cloud/case studies, there are like lots and lots of case studies from all kinds of companies, all the way from companies doing self-driving cars to cancer research, universities, and retailers. And you know time and time again, we're hearing similar themes from these customers. And some of these themes are things like they were able to reduce their downtime, reduce the number of outages by a significant margin, um, and they were able to do this while keeping the monitoring cost really low. So some of these customers were using other observability vendors in the past and spending the big bucks for it. Netdata was able to kind of help them improve what they were doing, but also save them a lot in terms of the monitoring cost. And not just the monitoring cost, but in some cases also the cloud service cost. So some of these customers who are hosting their services on AWS, on Google Cloud, and other cloud providers, and the visibility that Netdata provided them helped them understand and make those capacity planning decisions that maybe we don't need all of these servers running all of the time, and we could optimize the workloads further. And that led to up to a 30% reduction in the cloud services cost, which could be hugely significant depending on your infrastructure size. We already covered the fact that the mean time to resolution can be halved, and this is something that we've heard time and time again. And this is where your anomaly detection, metrics correlation, the out-of-the-box alerts, these things, really matter. Some of the other numbers here are just numbers that are just part and parcel of Netdata. Like I said, the installation takes a minute to run, and the dashboards that you see that I was showing you on the demo space are all out of the box. So you don't do any configuration. You're not creating them chart by chart. You don't need to learn a query language, which means that you install Netdata, you immediately get all the charts, and you get instant value. And that's always been the goal. So anytime we add a new feature, even if initially we might have some configuration burden there, we always try to bring it down over time. So this is something that the engineering team is constantly trying to do. The resource footprint is something that we've done very detailed comparisons against observability agents from whether it's Prometheus or Datadog or Dynatrace and all these other vendors. And we found that even though the Netdata agent is doing quite a lot of different things, including storage, streaming, alerts, anomaly detection, and machine learning, we're still able to keep it really lightweight, especially in terms of compute and even in terms of memory. So the resource footprint is something that we take very seriously. There are lots of users who are running Netdata on very light devices, IoT nodes, Raspberry Pis, and we want them to continue to be able to do this. And finally, we talk about the amount of metrics that we collect. On a full-fledged server, we could be collecting upwards of 4,000 metrics. It could go a lot higher depending on the number of applications that you have running there. This is almost 50 times the number that you get from most competitors. And since we do not charge you anything by the number of metrics that you're collecting, there are no limits to this. You can just say, collect everything and then figure out what to do with them at a later point. And the same goes for the collection granularity. We're collecting data every single second. And this is, in some cases, it's 30 to 60 times the granularity that competitors offer. In some cases, it's even more. Even in the case of advanced tools, they're still usually limited to like a 10-second granularity. And for the rare tools that offer per second granularity, they only do it for a very select group of metrics, like the critical metrics. But with Netdata, this 1 second applies to every single metric.
Sean, just a reminder on the time. We have about 10 minutes left. I think we can wind up the slides soon and get to the Q&A. But I think we're almost at the end, towards the end of our...
Yeah.
So let's get to it.
Yeah, I'll make this quick. So this is just a quick view of Netdata's architecture and the fully distributed or decentralized view of things. So in this view, you can see each of those nodes below A1, A2, B1, B2, C1, C2. Each of those things are a Netdata agent that's running on a specific server or a VM, or it could be a container or a cluster. In this case, they can be connected to Netdata parents. This is not a mandatory requirement. It's just a way for you to ensure high availability and to better organize your infrastructure. And finally, they're connected to Netdata Cloud. But as I've been mentioning multiple times already, Netdata Cloud does not centralize and store any of the data. All the data remains below the cloud, which means it remains in your own infrastructure. And you visualize anything on the dashboard by opening a tab on your browser, it's running a distributed query to pull the data in through the cloud onto your browser window. And when you close the browser window, all that data just remains within your infrastructure. The only time when you're not on the dashboard that any data is passing through the cloud is in the case of alerts, because if an alert condition is hit, we want to notify you about it, and that's going to flow through the cloud and into the notification mechanism that you've selected. And this is just, I think, reiterating the distributed pipeline about storing things in a local data agent, which will automatically discover, collect the metrics. It will detect anomalies. It will store them in a time series database, from where you can check for alerts. You can query the data from Netdata Cloud for visualization. And if you want to, you can export it to your own third-party database. You can stream it to a Netdata parent if you want to. And this is just a quick snapshot of all the Netdata features. I'm not going to cover the stuff that I already talked about, but you can see that you also have enterprise level features which organizations would need, like role-based access control, single sign-on, identity management, your enterprise notification integrations, and we also offer premium support if you need it, custom training and workshops. And even though Netdata always keeps your data on-prem, there is also the option to run Netdata Cloud in its entirety on-prem as well. So if you're running an air-gapped environment, if your organization is paranoid about data security, you can run Netdata Cloud on your own without any contact to the internet or to Netdata. So that's it from us. I guess if there are any questions, we can take them now.
Yeah, I think the questions have been pouring in. I was trying to handle some of them offline, but I think it'll be good to probably take some of them and start putting in there. Okay, so I'm starting from the last. So one of the questions that came in is, are there any kind of requirements on the agent, especially some Windows related configurations, etc.? Shyam, if you can take that.
Sure. So the agent, it runs pretty light. So almost any, we can share offline the links to the documentation, which talk about the exact requirements in terms of how much resources you need. But this is a very lightweight agent. So any, modern device that you have running Windows should be able to run it. The good thing is that we've also tested this on various different versions of Windows. And I think anything running Windows Server 12 to 2012 onwards should not have any problem in running the Netdata agent that we release. Even the older versions might be able to run it, but we've not tested it. We have tested all the versions from 2012 onwards.
Maybe Shyam, if you want to touch on the privileges, the admin privileges, is it only needed during install, but or also for running the agent and collection?
So you need to have the admin privileges to be able to install and run, so that the Netdata agent itself has the right privileges to collect the data. But once it's running, then you don't have to do any on-device administration that requires any privileges. And we've tried to reduce the configuration burden by making all of the Windows services auto-discoverable. So whether it's MS SQL or Hyper-V or anything, it should be automatically discovered out of the box.
Thanks, Shyam. I think another question is related to alerts. Maybe if you can share your screen. So it comes from Ellie. The question is, Can you please set up a custom alert or show us to set up a custom alert for a certain application or database? So we have a dynamic configuration feature. So let me show your thing on screen. So Sham, if you can just show how to create a custom alert. So yeah, so you can create an alert from the scratch, right from scratch, by mentioning what metric you want to create this on. But also maybe the easier way, Sham, would be from the metrics explorer. So on,
Yeah.
for example, you're looking for a database application and you want to create an alert. So go to the chart that maybe you know.
So yeah, so I'm gonna choose something related to Hyper-V here. So I'm going for Hyper-V CPU, and I just click on this bell icon here, and there are no active alerts that have been configured for this. So I click on Add Alert, and it automatically opens up this window, and you can see that it's already filled in the name of this metric or this context, and you can then you decide to give this configuration a name, and then you can choose how the alert needs to be configured here.
Yes, so Ellie, maybe we can share some links to documentation on what each of these fields mean. There's a concept of uh, database lookup. So you can say how long in the past you want to look at data, aggregate them. You may want an average, sum, max, whatever you want to run, and then define a threshold for warning and critical levels of the alert. So maybe we can share some links on to understand the concept, but it can be done from the UI. It should take less than a minute to configure an alert. And like Sham mentioned, you can submit it to one of your servers or to multiple nodes all at the same time. And this can all happen from the UI. Okay, quickly, let me take a few more questions. Okay, there's this question that comes in. Is it possible to monitor metrics from several servers locally, and how to connect it? Uh, and does Netdata require login to cloud?
So when you say several servers locally, um, of course, the Netdata agent can be installed on any number of servers, and each server you would be able to access both the local dashboard, and if you're connected to cloud, you would be able to see the overall view of all of them together. But like we mentioned, in the architecture slide, you can have Netdata parent. So let's say that you have 10 different servers, all of them are connected to the same parent. From that parent's local dashboard, you can access all of these servers. Now, the only requirement is that the Windows dashboard itself is part of a Netdata cloud feature. The Netdata agent is the open source component. The Netdata cloud is our proprietary. The cloud dashboard is our proprietary software.
Yeah, I think also additionally, Ruslan, if you're looking at setting up the Netdata agent only on one server and collect metrics from other servers remotely, this is possible. Uh, of course, you can scrape metrics through Prometheus, maybe node exporters and other ways for you to collect them locally and then beam them. But I think it would rather be better off, given how optimal Netdata agent is, that you can install the Netdata agent all over and centralize them if you need to with the streaming and Netdata parents enabled.
Yes.
But this is definitely possible, even
Yeah.
without having multiple
Yeah.
Netdata
So
agents.
no, remote monitoring using a Windows exporter, which is a Prometheus exporter, is definitely possible. We've supported that for quite a long time. But like Satya said, with the Netdata native agent, we've tried to address some of the shortcomings of the Windows exporter. So it is more optimal in the long run. But yeah, if you want to do that, it should be possible.
Yeah, quickly taking a couple of more questions, Sham, maybe for you. This came from Zed. Uh, it's about, can events be correlated from multiple sources, like seeing event logs from multiple systems at the same time?
Yeah, so this is something that we are actually working on. Currently, you can see the event logs from one system at a time. You would need to click on each of them differently. But we're working on a lot of improvements to the logs tab in general, and this is one of them, where we can correlate it across different servers, but also correlate metrics and logs together if you want to create metric charts from the data in the event logs, be able to do anomaly detection and alerting from the logs data. All of this is coming soon.
Thanks, Sean. So yeah, Zed, this is something that we're working on, and hopefully it comes out soon. But for the metrics itself, all the metrics are shown to you as aggregated charts across all of your servers. It's only for the event logs where you'll need to look at the event logs for each machine independently. So your correlation for now for the logs is per host, per server, but we're going to come up with a multi-node, let's say, correlation pretty soon. I think most of the questions that came in have already been answered. We've kind of run out of time, but if you have any last minute questions, guys, please feel free to send them out here. Maybe we can stay on for a minute or so.
Yeah, and even after the stream has ended, if any of the questions haven't been answered, just send us them offline. You can comment on the video. We'll try our best to answer everything.
Okay, there's one last question, which again comes in from Zed. Oh. Okay, sorry, I beamed the wrong one. Yeah. So can a dashboard created from different systems as well?
So if I understand the question properly, if you're talking about custom dashboards, then yes, the custom dashboard can have data coming in from any number of different nodes. You can have a chart which has the same chart having data, aggregate data from different nodes. You can have charts which are showing data from an individual node. You can have a mix of all of them together. It really is up to your imagination.
Yeah, maybe I think this is a point where Zed, just to make sure we all understand, Netdata agent runs on individual servers or hosts. Each agent has its own dashboard where you basically see the charts and the metrics relevant to that host or whatever you're collecting from that host. It could even be remote network devices, SNMP stuff, and things like that. But the Netdata cloud is where you get a single pane of glass, end-to-end view of your entire infrastructure. So if you have 100 or 1,000 or 10,000 Netdata agents, all of those are aggregated onto a single dashboard on Netdata cloud. So that's where you basically get an end-to-end view. So yes, you can basically have a dashboard that shows metrics across all of your servers and systems in your infrastructure. Okay, I think that's probably the end of the webinar. Thank you, Sham, for a very detailed walkthrough of Windows monitoring, but also Netdata monitoring in general. And thank you all, guys, for being here until the very end and some very insightful questions in there. Also, feel free to reach out to us after this webinar, either on GitHub, on Discord, on any of our community channels, but also via email if you have direct access to that. Thank you very much for
Thanks,
attending.
Satya. Thanks everyone who made it this far. Thanks for your time. Thanks for your patience.
Thank you, guys. Have a great day. Bye-bye.
Have a good day. Bye.